If you want to learn how to measure and plot temperatures, build wireless radio controllers, use servos to drive tools, or build weird things like, I don't know, a thermal camera, here you'll learn mechatronics in minutes. If you've ever wanted to use your ESP32 to get information from a website and display it, I'm going to show you how. The example that we're going to use is a simple weather station. I'm using data right from the National Weather Service, and it gives you things like the day, the temperature, and the weather conditions. I'm also getting the time and date directly from the web as well. I'm able to get up to 7 days, but because my display is a little short, I'm having to scroll through each of the individual days. If you're wondering why the temperatures are in a different color, that's because they're a different temperature. I wrote a small function to map color to temperature. So if it's cold, you'll see blue. If it's hot, you'll see red. I wasn't sure how to get web data, so I did a quick Google search. Just typed in National Weather Service API, and there you go. There is an API for this particular company. If I took a look at the pricing, free to use for any purpose and is a public service of the United States government, so my tax dollars hard at work. If you're in another country, you might have a similar service. Google that and find out. Also, I see the API is based on JSON, which is a pretty familiar term to me. It's basically data organized in a very specific format. I'm going to go to the General Use Questions page and learn a little bit more. They have a general FAQ and a grid point. This particular web page, how they operate is you specify a latitude and a longitude, and it will spit back a series of data for you. I've already created this URL, so I'm going to go ahead and paste it into my web browser. And within a couple of milliseconds, I get a JSON string back. You can tell by the brace and some keyword terms here. Down underneath the properties, you will find the grid ID, the grid X, and the grid Y. That is the information that you're going to need to know to build your next string to get actual information. There's not a whole lot of data in this entire JSON string. It does tell you city and state, but not a lot of useful information. I'm going to use that information to build my next string. They've also done that for you under the forecast. Notice how they've given you the exact format of what the grid ID, the grid X, and the grid Y must look like. So we'll copy that to the clipboard. We'll create a new page, and we'll just simply paste it right in. And within a split second, you get a whole series of data for this particular URL. Under the properties, we get periods, which there is an array of them, and I believe there is 14 elements, 7 days a week. And you get this afternoon, tonight, tomorrow, and Friday night. And you're going to get things like the temperature, the unit of measure, the wind direction, the short forecast, and a few other interesting things. If we go back to that previous page, there's another URL for hourly forecasts. So if we copy that to the clipboard, paste this in, and you know the drill by now, we're going to get, within a split second, a very, very large JSON string of tons of information. This is hourly, so this is from 3 to 4, 4 to 5, 5 to 6. Same information, the temperature, the degree of the unit of measure, wind speed, and a short forecast, and so on and so forth. Unfortunately, I was not able to use this particular JSON string. It's just too big. The person that wrote the Wi-Fi library wrote it string-based, so it is character limited to 65,000 characters. Thanks for all your hard work, but I wish it were chars. We could make it a little bit bigger. But don't fret, this particular site here has got plenty of information on it. If we take a look at our display screen and notice how I have the day, the weather condition, and the temperature all listed. I could also put wind speed on there if I wanted to, but this is something you can play around with. All right, now let's take a look at the code. Like I mentioned earlier, I'm using an ESP32, and I'm using the Arduino IDE to program the MCU. My display is connected right to my ESP32, and there's the pin, the information that I'm using. If you're not familiar with how to get a display working, there are plenty of YouTube videos to get an ESP32 working with a display. I'm using the Adafruit GFX and ILI9341 libraries. I know how to get them to work, and that's the ones that I use. I'm using the Wi-Fi, web server, and HTTP client libraries. And if you want to get the ones that I'm using, just copy that JSON string, here we go again, JSON strings, to your clipboard and paste it right into your file preferences under the additional boards manager, and you'll be able to download the exact library that I'm using. I'm using a time.h for helping me get time from the internet and in elapsed milliseconds, which is a great tool for doing an automatic. Sort of every 5 seconds update this, or every 2 hours update that. It does the counting for you automatically. I don't know how to rip apart a JSON string, but this library does. And if you know me, I've got to have pretty fonts in all of my displays and projects with displays. I'm using a flicker-free print library to keep the text from flickering every time I update it. And the location I'm in is 6 hours from GMT, hence the offset that I'm using. You're going to have to key in your home SSID and password and your latitude and longitude wherever you happen to be in the United States. Here are the base URLs that I'm using for the site points, the day forecast, and the NTP time server. I went a little over the top, and if you look at the display, you see the temperatures in different colors. Hot is red and blue is cold. And I've got a neat little function that maps temperature to color. Pin defines, as you can imagine, and ways that I manage my fonts. I have it defined for each of the font sizes, and I use that a little later on in the code. Bunch of defines for green, blue, light pink, and so on and so forth. And some variables for the temperature, forecast, time, and a few other things. All this is pretty standard stuff for creating objects to connect to a web server, JSON document, objects as well, and a few other things. And of course my elapsed counters. Connect to the internet as you would normally do with the begin method. And if you want, you can print the status of your Wi-Fi to get the actual IP address. Use the config time with the NTP server so you can actually get that all working. And then I get the internet time. Then optionally you can print the local time. First step that you've got to do is you've got to get your grid. You know, I don't know what my grid is, and you won't either, but you can easily find your latitude and longitude. You key that in, and this get grid will get the grid X and Y for you. Get the day forecast, then display the header and display the data. Pretty simple stuff. Then in a loop every second, I update the time. Every day, I go back to the internet and double check the time to make sure I have the correct time. Every 5 seconds or so, I update my scrolling capability so you can see each of the 7 days display when I only have enough room for 3 rows. Every hour, I'm going to check the forecast again to make sure things haven't changed or just get the updated data. If they have changed, I'm going to just blank the screen out and redisplay everything. Here's where I'm getting my internet time. There's a function called getLocalTime. You remember, we set the configuration earlier, so all I have to do is pass in a struct, and it's going to give me things like the hour, the minute, and a few other things back. Here's the value of the elapsed second counter that I'm using. I'm actually, the current time is actually an elapsed counter, so I'm going to tear apart the hour and the minute and build a unsigned long, and I'm going to assign that right to the current time, and that library will automatically increment that for me, so I don't need to worry about getting the milliseconds, getting the rollover. It just does it. Then every 24 hours I go back, I get the internet time, and I simply build that current time again. Then I let the ESP32 manage the time with its internal counter and that elapsed time library. Display a header, pretty basic stuff here. Just get the second, minute, hour. Build a buffer using the sprintf and display it using my time or flicker free print library so you can see a nice smooth update. Then draw the date and anything else that you might want. Then display the data. This is where you can get real creative and do whatever you want to do. Do you want to show icons? Do you want to show text? Do you want to show colors or whatever? I made it real simple. I just draw 5 rows and populate all of that information in there. Every iteration, I bump the row up by 1 so you can see how this thing kind of scrolls through. And all I'm printing is the time, the forecast, which is actually the Monday night or whatever, and then the actual temp itself. And here's I'm a little bit over the top. I'm using the get color to convert the degree F temperature to degree C, and it's going to give me the actual 565 color back, and I can use that in the set text color method to display the correct color. Print local time and Wi-Fi status. I'm going to skip those 2 things. You can read over that. Get day forecast and the get grid are the two real heavy lifting sort of functions in here. The get grid will start there. First, do we have a Wi-Fi connection? If we do, then we're going to create a HTTP client. I'll set the timeout to 6 seconds. You don't need anything that long. I just do that as a safeguard. Start you with your weather server path and build in your complete path with the latitude and longitude. And then simply pass that right into the begin statement. It's going to give you a response code, your typical 404 if the web page wasn't found, and so on and so forth. I've found this site to be pretty reliable. I usually get a 200 back. I am not error checking that, but I should be. That's something you could do. And then you get your JSON string, and I'm putting that into a very large string here. And I'm using a deserialized function on the JSON string object, and here's where all the fun can begin. This magical function right here takes that wild-looking string that we looked at earlier, and it prepares it so you can ask it simple questions like go to the properties and get the grid ID, and it will take you right to the properties, the grid ID, and give you that LOT, or whatever that data happens to be. Same thing for properties. And grid X, it's going to return 75. Properties for grid Y, it will give you 72. Then we're going to build a day forecast path so we can feed that up into another call where I create an HTTP client. We set the timeout, and I zero everything out just in case I couldn't get to the web page because sometimes it's down. Check for a web connection, pass in the day forecast, get the begin, get your response code. And here I do some very, very basic checking that if it's above 200, the service is unavailable, just return. And because I've zeroed everything out up here, I don't have to worry about a bunch of null data or bad data or old data. Then we move on to the next thing where we get the string for the JSON. And here I'm just printing it out so you can see it. And I'll let you run the code to see what that actually looks like, which will be just like this over here, by the way. Then we're going to deserialize that so I can ask it questions like the properties, the period, the iteration, the name, which will be Saturday in this particular row, the temperature, which will be right down here, 40, and the short forecast will be mostly cloudy. So the library does a really good job of taking this JSON string and sucking all the relevant information that you need out of it. Last but not least, I close the HTTP object so I can open it up for running something else. Get grid, we just talked about that. Get color, a real neat little function that I wrote to send in the temp C, and it will give you the RGB value back for your Color 565 monitor. Well, that's it. Hopefully you learned something, and I had a good time working on this project. I learned a lot about how to get data out of web pages or web servers and use JSON decomposition to get information out of it. Maybe I'll work on another one like how do you get stock quotes. Well, that covers this week's lesson. If you learned something, give me a thumbs up. If you have a tip to share, leave a comment so my subs can learn more. Thanks for watching.